Goodness. Here we go, everybody. This is Miss Oshier.
And Miss LaHart.
And here we go. Let's expand and condense some logarithms.
Oh, baby. Now, log and exponent laws kind of are the same thing.
Because a log is an exponent.
Log is comparison. So remember back when we were multiplying with like bases, we added our exponents? When you have log properties, you can split those up if you're multiplying.
Now it's log base b of x times y. You can break that into log base bx plus log base by. Notice the base is staying the same. You're just breaking up what's inside the parentheses.
True statement. And then quotient, what do you think if you're multiplying or you're dividing? You subtract your exponent. So again, same thing.
Oh, I know. Power to a power means multiply. So anytime you have an exponent with what you have the log of, that we always put it out front. You could technically write it next to it, but this y is being multiplied by the log.
There we go. Oh, my animation.
Oh man, it's okay. We gave you this one. So we're multiplying, so we can break it up to addition of the two separate pieces.
And then if you can evaluate a log expression, you do it. Do you know?
I sure do. It's 2.
There you go.
It was also right there.
Yep, it was also right there. But let's see if we can make it a little bit difficult. All right, we got a power and we have division.
So there's division, so I'm going to be subtracting. Ooh. But then this power to a power means that I can put the 2 in front. I can also evaluate this log. What am I going to do first? Both. So 2 comes out, log x. And then remember, this is base 10. That's the common base. And with 10s, you can just count 1, 2, 3 zeros. Yep. So that's to the third
What's
power.
The exponent on a 10 to get 1,000? 3.
Look at us go. All right, this one's tricky because there's a hidden secret log rule in it. Let's see if you can find it.
We have division, and then we have a radical. But if you remember back to your first chapter, and I think this pops up. Oh, look at that! It is square root of x is the same thing as x to the 1/2.
So that half can hop out. So can the 5, using the same power to a power rule. And I have nothing further I can do there because they're variables.
Yep, so we're good to go. Natural log has the same exact rules, okay? Subtract.
Now remember here, this is technically a base e, okay? So after we use our power to a power rule, ln e of e
is just 1.
Is 1, so that's just a 2.
Okay.
Look at us go.
Oof.
Now let's condense. So let's go backwards. So as you can see in these two examples, when you had plus, you really can just write the log base 6 one time and then multiply the a and the b, and then don't forget these guys are exponents.
Yep.
So you can also use it to condense things.
Way to have an animation, Miss LaHart.
You know what works really well. So then you have your subtraction here. So that became division, and then the 16 and the 4 went back up into exponents, and the a and the b are back where they were.
So that's condensing. Now, oh, look, here's another one just
Let's
to make
condense some more.
Yep.
Okay, so again, addition is going to turn into multiplication.
And then we see that 1/2, which we talked about in the prior example, knowing that that's square root. Now, you'll get full credit if you write a to the 1/2, but it's like you really know what you're doing if you write it with the square root.
If we saw that, we'd be like, oh,
snap.
Well then, okay.
4 has 3 different pieces, and I'm going to pay attention to the parentheses. So I see subtraction first, and then that quantity, so I know that that quantity goes underneath. We're dividing by that whole thing.
This quantity first.
And then we got powers all over the place, so that's where the 1/3 pops up top and the 1/5 pops up top. So you can write it, or you could take it one step further and write it with the radicals.
Look at that. So pretty. And notice that they were all log base 5s. All right, so if a equals log 3 and b equals log 2, then which of the following correctly expresses the value of log 12 in terms of a and b? Okay, you got to kind of think, can you get to 12 using 3 and 2?
And you can use any powers of them. So like, probably I'm thinking 2 squared is 4.
Oh, yeah.
And then 4 times 3 is definitely 12.
Definitely is.
So then, if they want to write it with log properties, I see multiplication, so I split it up with the positive. That 2 had an exponent, so that popped out front.
Okay, now, they're telling you log 2 is b, so a b can go in there. Log 3 is a, so an a can go in there. Oh,
look at that.
Nice animations on this one,
Well,
Miss
that
LaHart.
one pulled together. So then that expression is equivalent to 2b plus a.
I'm sorry, I went too fast.
No, that's okay.
All right, log 7 is k, then log of 4,900. Holy mackerel.
Now, if these types of equations, you can always use common log. Do you see how it's log 7, so you know that that's base 10? So we can use a log base 10. 7 and 49, 7 and 49?
7 squared.
Definitely 7 squared. And
0,
then,
0, 100.
okay, so we're on the right track. You would do 49 times 100. You would get 4,000. You can rewrite that.
Ooh.
The 2 pops out front.
go.
And then we know that the log of 7 is equivalent to k, so that's going to turn into k. But what's the log of 100?
What 10 to what power is 100? 2.
There you go.
Right.
So
So it
these-
showed up.
Oh,
my
it did.
dramatic pause wasn't as effective.
That's okay.
That's-
You're working with, I guess you could
yeah,
say. Is there one more?
No, that's